Hello. How's it going, everyone? We're starting a couple minutes early, but if anyone is already here, which it looks like there's a couple people, let me know in the chat if you can hear me. It's always good to double check. I'm gonna test screen sharing real quick as well. And let me know while we're waiting just a couple minutes to get started. Why are you interested in ML monitoring or machine learning in general? Actually, a good question too, and I'm sure I'll ask this again as more people join in. But maybe it's, have you ever put a machine learning model in production before? Because we're going to be talking about monitoring today, obviously, the name of the talk. But that's kind of around, having a machine learning model in production and some of the things you might want to watch for. So I know for me, when I put stuff in production, stuff always changes in the environment, and you have models fail in interesting ways, and that's where we're going to kind of talk about how to prevent that or catch that quickly today. And I'm just going to double check that all the streams are working. And I'll share some links in a second, but I just want to mention that if you're watching on YouTube, all the links are in the description. And I'll share the most relevant links in the chat as we go, because we're also streaming to LinkedIn. And we'll wait just another minute before we really get going. But again, in the chat, maybe put in kind of what you're working on, what kind of models you've been building. If you've done a lot of machine learning, are you learning machine learning right now as a student? Are you working on stuff in production? Let us know in the chat. It's always more fun for me as the presenter, but also for everyone else watching too, to kind of get a feel of who else is here with you. And I'll go ahead and grab a couple links and I'll share them before we really get going here. One is, we'll talk about this in a little bit, but we're going to be using an open source library called ylabs. You can find more details about it on GitHub. I'll share it in the LinkedIn chat as well. Also, it's open source, and we always appreciate a star if you want to give us one. And then the only thing you'll really need to do to follow along, because we are going to do a lot of hands-on code parts. That's what makes it more fun to me, at least, when I'm learning something, is doing hands-on stuff. We're going to use a system called ylabs to do some of the ML monitoring today. So you can create a free account there. There's no card or anything required. And once you have that set up, that's kind of the really only setup piece you should do. Everything else we're going to do during the workshop. And then I'll share one more, actually. And again, these are in the YouTube description. I see a lot of people just joined. Everything should be in the YouTube description if you're watching there. But I'm just sharing these links in the chat if you want to check them out before we get going. There's also a Slack channel, so if you want to stay connected after the talk, it's a great place to ask me questions or anyone else on the team questions, as well as staying connected with other people. So, I like going to events and staying connected and seeing who else is there. So again, also, if you want to throw just in the live chat right now a little bit about yourself, maybe why you're interested in machine learning or ML monitoring, do that. And all right, we're going to go ahead and get going. Let me share my screen. Put it in presentation mode. All right, so this is ML Monitoring 102. So we did a 101 last week. We're going to do a quick recap today. So this is kind of standalone. If you missed the first one, you should totally be fine. There's just some things we went a little bit more in depth in the first one. And we also showed off some other functionality of the open source library, using it in your own Python environment. So if you do want to check that out, the recording is on YouTube. But don't worry, if you didn't come to the first one, you'll be fine to go through this whole one on its own, and maybe you just want to go back and cover some of the stuff that we won't in this one. Hopefully this is a super friendly introduction to ML monitoring. No previous experience is expected, but definitely knowing some Python and machine learning concepts will be helpful. That's what we're going to be using today. And we're going to do just a recap of some of the high-level concepts from last time. We won't spend too much time on it, so it won't be that many slides, not that much time in here. Most of it is going to be hands-on, which I think is way more fun. And just keep in mind, you can't learn everything in about 30 minutes or however long it takes us to go through. So if you weren't here last time, especially, we're going to kind of cover some stuff super fast. So it might feel challenging or fast-paced depending on your background, and that's totally fine. Just keep learning after this workshop. You can go back and watch the first one as well. And then also you can ask questions. So ask questions during the talk. I'll try to get to them, but also you can join that Slack channel that I posted in the chat, and that's linked in the description. And that's going to be a good place to ask questions later after the workshop. A quick introduction about myself. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at ylabs. We build tools to enable observability around ML machine learning applications and data pipelines. We're going to see some of that today. We have an open source library called ylogs, and we also have a platform called ylabs. We'll be using both of those today. For about over a decade now, I've worked in software or hardware, mostly with startups. And a couple agencies around in Seattle and also in Central Florida. And I love making things with technology in general, so I always have a ton of different hobby projects going on. And again, if anyone wants to post in the chat, do they have any fun projects going on right now that they want to mention? A little bit about you. So at the bare minimum, I see quite a few people in here, but no one's posted in the chat yet. If you don't want to talk about a project or why you're interested in machine learning, at the bare minimum, it's fun to kind of put in, where are you watching from? So it's fun to see a little bit of the reach to the audience. There's also, I know sometimes like a 30-second delay or something when I ask a question to it getting to you on the stream. So I'm going to wait just a minute, but you should definitely put in the chat where you're watching from. Maybe also put in why you're interested in machine learning monitoring. And like I mentioned as well, I think a good question to answer would be, have you ever put a machine learning model in production? I think that's a fun one. And then again, the link to the Slack channel is below. I love connecting with people, and it's kind of fun to stay connected with the other people in the audience. So it's going to be a good place for it. And there's an introduction channel in there, as well as a shameless promotion one. So if you have a product or something you're working on and you want to post it in there, feel free to do so. Someone said, hey, they're working on an NLP project related to palliative care in clinical notes. That sounds interesting and really cool. There's so many awesome applications, and it seems like a lot of NLP, but also computer vision in the healthcare industry. It's super cool to see. All right, so setup for this workshop, all you need to do is have a Google account already. You probably already have one, so if not, you can go create one, but we're going to be using something called Google Colab today, which is kind of Google's way of hosting a Jupyter notebook. And then again, I'll post this one more time. You'll just want to sign up for free here if you want to follow along with all the code portions today. Again, there's no card or anything required, so it should just take a minute. I think you sign up and you have to verify your email, and that's it. So today we're going to be using Google Colab, like I mentioned. We'll talk more about this when we get to it, but it's kind of the code IDE and instance that we're going to be running everything in today. And it's free and easy to get started with. And then we're going to be using scikit-learn. We're going to train a simple machine learning model. We're not going to spend a ton of time on that today because most of this is actually about once you have a model, what are some things you can do to kind of look at it. And then we're going to be using ylogs. That's the library I mentioned for data profiling, data logging. We're going to look at this a little bit later, and then we'll use ylabs. Quick recap, what is ML monitoring? Again, we dive deeper in this in the last workshop, but I'm just going to briefly kind of sum up some of the key points again. Is once you put a machine learning model in production, often things kind of change over time. One way to monitor for that is to basically collect different statistics about different parts of your pipeline and keep an eye out for these things like data drift, which kind of happens when the input data to your machine learning model that's deployed changes from the distribution that your model is trained on. So you might train and evaluate your model and it looks great, and then you put it in production and it's going to start seeing data that's probably never seen before in the training model. And if it changes too much from that training distribution, something happens called data drift, and your model might not be performing as well on it. Data quality, this could be anywhere. It could be manual entry errors. It could be something in your pipeline. It could be that your sensor is broken or your camera got moved if you're doing computer vision. You could have a schema change updated from a library. And then you have things like your model outputs. You can measure things like volume, system metrics, concept drift, which is kind of if your model's getting stale, like you trained it 10 years ago on the housing market. And if you use that model now today, it would probably be very wrong if it's trying to make price predictions. And then you want to monitor model performance. These are probably things you've heard about before, some of them anyway, like accuracy, recall, precision, and then also business KPIs. Is it meeting those needs? So we have a saying, bad data happens to good models, which I think is a pretty good thing to remember. You could spend a lot of time in your model, and it could be a great model you put in production. Data is probably going to change depending on the environment going in. And you want to be kind of consistently looking at this to make sure that if it does change, your model's still behaving correctly. And there's also some other things not quite listed in here that we're going to go deeper into future workshops, such as like bias and fairness and explainability of your models. So again, this is just super quick recap, but a high level system architecture of ML monitoring could be you have your pipeline and your model here, you're collecting various statistics, you're going to analyze and measure those statistics, and then do something with that, such as like looking at reports. You might have automated alerts and notifications, or you might have triggers and workflows. So there's a lot of cool stuff you can do around, detecting data drift, having someone like automate a job to have annotators annotate it, get the ground truth, then measure performance. And if performance did drop and the data just looked like it drifted, it wasn't a quality issue, you could then retrain your model on that new data, and then hopefully it'd be a little bit more robust on the new data coming in. So again, we're just running through really quickly. We talked more about this last time, but how to analyze change in an ML application. Just some key points here. You have your pipeline, so you kind of might have an idea where things might fail, and it's good to be monitoring at all those different points. So it could be, every time you're doing a transform on your data, you want to make sure that it looks the way that you're expecting. But at the bare minimum, if you're just starting, like have a model in production, you want to get monitoring happening. Monitor the model inputs so that the direct data going into your model, and you can see if that changes a lot from the training distribution. And then you also would want to eventually probably measure performance. Usually ground truth isn't available right away, so you can also monitor the predictions and see if those change a lot, and then go get that ground truth and kind of see how your model has been performing. In my experience, a lot of stuff can be caught with just the inputs. Obviously not everything, but if there's a big quality change or a big drift in data, you're going to notice it directly in that model input. So having that as just the bare minimum can show a lot about what's going on in your deployed model. All right, so that was enough slides. Like I said, we were just going to go super quick today. We spent way more time on them last time. Let's get into some coding parts. And I'll also say if anyone has any questions, go ahead and throw it in the chat. And I will be looking at it once in a while, and I'll try to get to them. If not, I can get it at the end of the workshop or later in the Slack channel. Is a good place to ask. So I'm going to share these in the chat, but they should be in the YouTube description as well. This is going to be the Colab notebook that we're going to be running all the code out of today. Make sure I get this again in LinkedIn. And on LinkedIn, I don't think the links are clickable, so you have to copy that whole URL and paste it into your browser. All right, so open up this link, and if you didn't already, you can sign up for the ylabs account. Again, link should be in the description. I guess I'll share this one more time as well. So I'll give everyone a minute to do this setup. So open up this Colab, create that account. Once you have this Colab open, what you want to do is go to File, save a copy in Drive. So this is going to give you your very own copy of Google Colab in your own Google Drive instance. So you'll be able to edit all this code and run everything and hopefully not have any issues. The nice thing too is if you want to play around with this and edit anything and kind of see what happens, you can always come back to this original link and make another copy from there. So don't worry about breaking anything. You won't be editing the original one. Let me zoom in a little bit. And again, I'll give everyone a minute to do those two steps if you haven't already. File, save a copy in Drive, and then set up the account. There's also a link in here in the Colab notebook. So if you open up the Colab notebook, you can click this link and set that account up as well. And I'll talk a little bit about what's going on in Google Colab while everyone's doing that. So this is Google Colab. It's kind of Google's way of hosting a Jupyter notebook. If you've never used a Jupyter notebook before, it's a popular tool in data science and machine learning engineering. It allows you to write this text like we see here and code like we'll see down here, and we'll see way more in a minute, all in one place, as well as look at visualizations and output. So it's kind of this cool document that's interactive that you can save visualizations in, write text. So it's really cool for documenting things. and code in all in one place. And Google's way of hosting it actually gives us a whole little instance where a whole little Ubuntu instance, so you actually can pip install new libraries and stuff in here. And I'll briefly mention, we don't need to do this at all for this workshop, so don't follow along right here, but you can change a runtime type and actually add in a GPU or a TPU. So it's a really cool tool to get started with deep learning as well if you don't have a GPU at home. Or a TPU, which is a tensor processing unit, very similar. So it's really cool if you're trying to learn deep learning or something like that and you don't have a gaming rig with a GPU. You can get started on here for free, and then they have like a pro tier and stuff. All right, did anybody make a copy? If one person in the chat wants to let me know that it worked, that'd be cool. And to really make sure it worked, you can go ahead and run this first code cell. So this is a code cell. You can type code in here. There's this Python print statement just saying print hello. I'm going to go ahead and hit run. So you can click this play button. That's going to run the code cell. You can also, when it's highlighted, hit shift enter. So you'll probably see me hit shift enter a lot, not clicking that play button. It's up to you. When you press shift enter, it runs that code cell and then moves to the next one. So you can keep hitting shift enter, which is kind of cool. You saw it took a few seconds to get started. It initialized our instance, and now we actually have this little instance of this Jupyter notebook running. Like I mentioned, it's actually a whole instance, so you can actually do terminal commands in here as well. We won't use this much today, but you can say exclamation mark something. This is listing all of the items in the directory, so we can see that there's some sample data already in there. So let's go ahead and do the first part of setup. We're going to pip install that ylabs library. This should just take a few seconds. And then one important thing to note, once this library is installed, we want to restart the runtime, so a button will appear, and you'll have to click it. If you don't click it, you might get an error later, and I'm guessing one of you isn't going to click it, so I really want to emphasize, if you get an error down the road about the ylabs library, chances are you did not hit that restart runtime button right here. So I'm going to go ahead and do that. Restart runtime, hit yes, and then you can see it just restarted up here. It's initializing again. And then we really should be good to go. Everyone following along so far that wants to follow along? Did that work? You'll also see, so there's a couple collapsible sections here. This has the content from the last workshop. We want to be in this 102. So since you copied it today from me, this is expanded, but you can expand and kind of collapse these. So if you come back to this notebook later and this is open or something like that and you want to get back to that 102, you can easily click this little arrow. But also if you want to go review more of the ylabs library like we talked about last time and stuff, you can come back to this later after this workshop and kind of run all the code cells there and see some of the stuff that we're not going to cover today. All right, so let's go ahead and import some libraries. And I didn't mention before that Google Colab also comes pre-installed with most of the common machine learning libraries like NumPy, Pandas, scikit-learn. So we actually didn't have to pip install them. They're kind of already there. You can pip install specific versions though, because it usually has the most updated version, which can cause issues with your project sometimes. And we're also just going to do a little setting on Pandas to display all the columns because we want to look at a profile. Which you'll see what I mean in a second. All right, so let's train a machine learning model quickly. Also, just want to check again, did everyone make a copy? They're following along, no errors so far. I haven't heard anything about errors, so I'm gonna assume there's not. But if you do get something, let me know and double check that you did restart the runtime. All right. So let's train a model very quickly. We're going to use the iris dataset, classic dataset, but don't worry, we're going to be doing some more interesting things with it than maybe what you've done before. If people don't know, if you're kind of new to machine learning, everyone's probably used this dataset at some point, and you might have used this dataset like hundreds of times by now. But don't worry, we're just going to train a model in this dataset, and then we're going to look at some hopefully more interesting data with it. We're just going to kind of train a baseline model so we can kind of monitor the results from it. But I will walk through what's happening here if you are new to machine learning. I'm going to go ahead and run the cell. But from scikit-learn, we're importing neighbors. There's a popular machine learning algorithm called k-nearest neighbors. We're going to use that, and I'll talk a little bit more about it in a second. We're going to set the neighbor parameter to 5. Again, you'll see what this is in a minute when we go over the intuition of this model. we're just going to create the feature and target variables. So features is what we train on. That's going to be these sepal and petal length and width values, and we'll see what these look like again in a minute. And then we're going to split that training data set up into training and then a testing. So we're going to use 30% of the data for testing. We're passing in the X, Y values, which is the features and the target values to train on. We just have a random state that we can come back to if we want to see how our data was shuffled. And then stratify just means we're trying as much as possible to get a pretty even amount of the different classes. So there's 3 classes of flowers in this case. And we just kind of want to make sure that our training data has a pretty even split of that. And then here we're calling knn.fit. That's the actual training of the model. We're mapping those feature values and target values. And then here we're just getting some predictions so we can get a quick evaluation of our model. And based on the testing data, that 30%, our model was 97% accurate, pretty much 98 if we round it up. So again, just super quick, we're not going to spend too much time on this. We're going to go in and see kind of what predictions look like now. But just to cover a quick intuition, KNN kind of works like this. This is a little oversimplified, but if you have, this is a 2D plot here of those flowers and the sepal, in this case, sepal length and petal width, kind of how it's plotted. If you have this new piece of data, this black dot came in, and in this case, if the K number was set to 4, that 5 neighbor value that we had before, this dot is looking at the 4 closest neighbors. So 3 of them here are the versicolor, and 1 is the virginica. In this case, you say, well, the majority of the data that's close to me is versicolor. I'm going to go ahead and predict that this is that. And it might have a confidence score, saying, well, I'm like 75% sure that I belong to that flower class, but maybe I belong to virginica because 1 is in there. So pretty simple machine learning algorithm where it's just kind of looking at the distance between all the data and those targets and then saying that I probably belong to this one that I'm the closest with. And this is important for troubleshooting our model in a bit. So keep this in mind. A little bit later, we're going to see maybe our model isn't performing super great on some of the data sets, and keep in mind the intuition. All right, so don't worry too much about this code cell. Might look a little ugly. I'm just importing a whole bunch of CSVs. We're going to kind of emulate with these CSVs running our model for days. So we're going to loop through these in a little bit and pretend like our model was running for 7 days and see the results here. And then I'm just splitting up the feature values and target values. So I want to run the model just on the features first, and then we'll come back to the target values in a little bit. We have our data frames. We're going to loop through these, again, simulating kind of running our model for 7 days. And if you want to see what one of these data frames looks like, it looks like this. We have our sepal length, width, and our petal length and width, and then these are the values in there. And so we're going to be making prediction on these. So we're going to create logs on all these data sets and then push them up to ylabs to kind of visualize them. So again, we talked more about ylogs in the last workshop, but it's an open source library for logging data pretty much of any kind. Users can generate summaries of their data sets called profiles. So we'll pass in like this whole data frame. We'll profile that data set and get some really lightweight statistics about it. We'll see what this looks like in a second when we actually create the profile, but it's pretty cool. They're super lightweight, they're efficient, they're mergeable. There's a lot of cool stuff you can do with that, but with these kind of summary statistics, you can do a lot about understanding your data set and see how those distributions of those statistics change over time. So again, we'll see what this looks like in a second, but also you can learn way more at the ylogs GitHub. And there's a ton of examples in there too. So if you want to go through and like someone mentioned doing NLP, there's some NLP examples. There's also an experimental folder that has a lot of the cool stuff around embeddings that we're working on right now as well. So let's look at what a profile looks like. To create the profile, we're just calling y.log on one of those data frames, just the first one in this case. And then we're creating something called a view that creates this kind of view that we're going to be looking at, and then we're going to look at it in pandas. And this is what our output looks like. So we can see a few things in here. We see the cardinality estimate that's saying, well, for our petal length, there's about 42 unique values in there. We can see that there's 150 rows. That's how many, the count. That means how many rows is in your data set. And then the cardinality estimates how many unique values per feature here. If we scroll over, we'll see some other things like counts not a number, 0, counts null. In this case, they're all 0, so our data set's actually, not super crazy. It doesn't have any broken things like not a number in there. And then we get some distribution metrics like our mean for each of the features, our median, our min, our max, things that you might think about, kind of summary statistics about these kind of features. And so just with these, we can actually do a lot of really powerful stuff. We can also look at the counts, so types of integer, fraction, in this case are all fractions for this one. Was there a string? So we talked about in last time also doing validation in your Python environment. So you could use this profile and say, well, don't run the next step if one of these is below a certain number, or if a string is in there, because everything should be a fraction. You can run data validation using ylabs profiles, which is pretty neat as well. But in this case, we're going to be logging all these distribution metrics up to ylabs and then seeing how we can measure them to see how much our data has changed. All right, so in order to log that, we just have to do one more setup piece, and then we should be able to run the rest of the code. We want to get our org ID, our API key, and our model ID from ylabs. So I'm going to go to my ylabs account. And if you didn't sign up yet, I'll share this again. This is just to our web page, but you can go to login, hit login from here, and then hit sign up. I guess I can get the full URL. Share this in the LinkedIn chat because I did see someone getting some links over there as well. All right, so once you're in the platform, is anybody in the platform yet? Give everyone a few seconds to do that if you didn't already. All right, if you're a little behind and you have questions about any of the stuff I'm going to go through, feel free to ask me in the chat. I know sometimes someone will say, hey, can you go back about where to get the API key or something? Once you're in the project or in your ylabs account, you should just have one, or maybe there's 2 demo examples in here. If you do want to delete any of them, you can go to settings, go to model dataset management, and then you can hit edit models, and you could delete any of the existing ones you want to get rid of. I think you can have 2 or 3 just in the free account. So I'm going to go back. I'm going to hit create project. We want to set up our own model today and learn how to get our own data into the system. So I'm going to hit setup model. We come back to this page that we were just at where we could also delete the models. So if you hit setup model and you want to delete any of the old ones, feel free to do that. And then I'm just going to give this a name. I'm going to call this March 15th Iris, but you can give this any name you want. And then I'm going to set the the asset type to classification model. So we're going to do this because we want to look at the performance metrics later. So when we upload ground truth, it knows what performance metrics to calculate. So now go ahead and hit add models or data sets. You can leave everything else as default right now. Now we have this new model. My model number is model 112. Yours is probably going to be 0 or 1 or 3 or something like that. So I've been obviously making a lot of models in this account. So copy whatever your model number is, or just remember it and come back over to your notebook and then paste or type it into this model ID area. You can see I accidentally copied over an extra space. Make sure you don't have any spaces at the beginning or the end of these strings. So let's go back to the ylabs platform. From this page, just hit this access token tab up here. This is where we're going to get the last 2 things. Again, I'll call this March Iris. You can call it whatever you want, but this is just going to create an API key for us. Copy that. Go back in here. I'm going to paste my API key. No extra spaces or anything. Looks good to me. One more thing to grab is our org ID. This is in a couple places here. It's this string here. It's this string here. It's also in a drop down if you click this little person icon. So I'm going to go ahead and just copy from here and copy it into my org. Again, no spaces or anything. Looks good to me. And then run this code cell. And I know it can take a few seconds for everyone to do that. So I'm going to wait or pause just for a few seconds here. And somebody let me know if they're following along. Were they able to get those keys? Did they have any issues? Is everything working good? No comments of errors or anything. So again, I'm going to assume everything's going good, but if you do have any issues, let me know. All right, so let's go ahead and do part of the, or what I think is the most fun part is writing our profiles and then looking at them. So we're going to import the ylabs writer from ylogs. We're going to write a single profile. So we saw those kind of statistics in that pandas data frame before. We're essentially writing that profile up to ylabs now into that new project that we just created. So let's go to the ylabs platform. I like just hitting this ylabs logo up here. That's going to bring me to the home page. We can see that our model is now receiving data. It has 4 inputs. It doesn't have any outputs or anything right now. And we can see the date range is just today. So let's go ahead and just click on this. And this is our little summary tab. There's not much in here yet, but it does get more interesting as we write more data to it. Someone said they're stuck on access tokens. Is there something you're stuck on, or is it just you're a little bit behind? If there's anything you want me to go over again, let me know. Once you do write the data or get your access token, again, let me know if you want me to go back over anything. But once we've written that first profile, let's go to this input tab. Let's click on this first one, the petal length. And then we can see, this isn't super interesting yet, but we can see our first profile is up here. So on today, 3:15, we have now the profile, and we can visualize, we see the, our median, we see the min-max very easily with these kind of dots. Might be hard to see if you're just watching, but I'll zoom in a little bit so you get this profile. And now let's go ahead and write more profiles to it and see what our data looks like over time. So in this case, by default, if you just upload a profile like we did, it's going to take the current timestamp and put it in. So like today, 3:15. Let's go ahead and run this code cell. We're doing the same thing we did before, except for we're just looping through all those data frames and setting a date time. So by default, it's the current time, but you can set a specific date time. So we're looping through those profiles and then just subtracting a day for each one. So it's going to go backwards 7 days and write a profile for each day. Someone asked, where do they find the API key? So go into the ylabs platform. From any page that you're at right now, you can go to settings and then go to access tokens. And then you can create a new token here. So new token, whatever you want to call this. And then create access token. That's going to create this API key that you want to copy over. And then the other one we got was this org ID on the same page. And then the other number, if you didn't get it, you again, just on the same page, all the tabs to get all the tokens are right here. You can hit model and dataset management, and you can go to model, whatever the one is that you created. In my case, it's 112. So access token tab, model and data management tab, and you can always get to those by going to settings. And then, you know, access token takes you directly to this tab, but you can navigate to the other tabs here as well. Like someone else asked that in all caps, but then they said, sorry about the caps. I do that all the time. And it sounds like you're angry. But I know you're not. All right, so I'm going to go back. Let me know if you still have issues with that. Let's go back into our project here. Let's go back to the inputs. And again, we're going to click on the petal length. And we can actually see just from this little page that, you know, more data is coming in now. Petal length. And now this looks pretty interesting. So we have 7 days worth of data here that we can look at right here. And I'm going to encourage you to kind of hover over these. So each day gives you some information about it. And let's look at just even one of the, oops, accidentally clicked something. Let's look at just like the median in this case. It goes from 4.2 on one day, 4.3 the next day, 4.2 the day after that. And then all of a sudden this profile jumps all the way to 9.2. That's a pretty big change. This one where we can see that, I don't know, something's going on here. There's a higher max and maybe a lower minimum. The median is still around 5 though, so not a huge jump from these. And then this one, this is interesting. The median's 0, the max is 0, the min is 0. And if I scroll over one more, this kind of goes back to looking normal. To the other profiles, median is 4.2. So what are some things that you might be that you think might be happening to our data here? In this case, right, like this, maybe this is a form of data drift where let's pretend this isn't the real case, but if we were saying, well, we measured all the flower lengths in the, I don't know, winter or fall or something like that, and then the summer they got really big, we would want to retrain our model on this new data where everything is clearly much longer now from our initial measurements. This one's interesting because most of them are kind of within the realm of our other data, but there are some things that go really high. There are things that go low. So that could be some sort of data quality issue. Or again, maybe we had a batch of flowers that have way more variations than the ones that we originally measured. And this one is all zeros because everything here is zero. The median, max, and min is all zero. So this is just a profile of zeros. That might be some sort of data quality issue. And then this one kind of goes back to what we assume right now are kind of normal distributions for our data. This is cool. We can visualize it and kind of debug it this way, but I'd rather have it tell me when the data looks weird, right? So I don't have to go here every single day to figure this out. So you can set up a monitor, click this button here, or you can go to the Monitor Manager tab. I'm going to hit this one. Now you see some presets that make it really easy. We have things for like data drift, data quality, model performance. I'm going to go ahead and hit configure on this data drift one for non-discrete values. So we're going to be looking at essentially numerical values, and we want to measure for data drift when something changes quite a bit. So go ahead and hit configure. We'll look at all these settings. We can see that we're going to use the entire data set. Segmentation is actually something we're going to cover in the next workshop. So kind of a way to segment up your data and see how it's performing on specific classes or features. In this case, by default, right here, the Hellinger distance is 7. Hellinger distance is something that we use to measure drift, how much our data has changed. So putting this number lower is going to make it more sensitive. So the less it changes before you get a monitor, and this is something you'll want to kind of tweak depending on your sensitivity that you want on your data. And then by default here, we have the 7-day trailing window. And this is kind of nice. So even if we don't have other data to compare against, we could be looking, in this case, the past 7 days and see if any of the data profiles look very different from the other ones and kind of trigger an anomaly alert on that. We're also going to look in a minute doing a reference profile. So a reference profile in this case, like if you're just putting your machine learning model in production for the first time, you might use the training data set, create a profile out of that training data set, and then compare against that training data set saying, hey, if any of the new data looks very different from the training distribution, then I want to, get an alert about it. And we'll see how to do that in a minute. But for now, we're just going to look at these past 7 days, and it should already be enabled since we hit configure. Let's go ahead and go back to that input tab. Click pedal length again. And now we have this preview now button here. So we can hit preview now. And it should just take a few seconds. And now we see we have a preview of 2 alerts happening. And as well in our little drop-down thing there, again, it might be hard for you to see. But if you're following along, you should be able to see it fine. I'm going to zoom in just so you can. So we have metrics like this. The quantile upper and lower thresholds, the median, the max, the min, and then now we have something called the drift distance down there. So when you see this profile that everything raised up a lot, the drift distance is really high. So it's almost no overlapping values essentially in our data set probably there, at least on this feature. And then if we go over here, there is a pretty significant drift distance, but it wasn't at our 0.7 threshold. So if we determine that it should have triggered here, we just want to make that threshold more sensitive. So we could say, well, if it goes over 0.5, trigger an alert as well. And then the 0 had a huge drift distance as well, like nothing else, probably had all zeros in there. So that was also triggered. So let's go back to our notebook really quick. And we're going to upload a reference profile. You do that very similar to writing a single profile, except for we just call this option in there called reference profile, and you give it a name. I'm calling it Iris Training Profile, and then we write it up like we did with the other ones. I'll go back to the platform here. I'm going to go back to the monitor manager. We'll go ahead and just edit this one. You can also have multiple monitors. You can also do fine-tuning, like custom monitors with JSON to really kind of monitor for anything that you want. There's a lot of customization in there. We just have the presets to kind of make it easy to get started. So let's go back and let's edit that Hellinger distance to 0.6, so we'll just make it a little bit more sensitive to drift. And then instead of looking at the past 7 days, we'll use a reference profile. So I'm gonna hit this drop down. There's only one reference profile in here, but you could, create any profile as you want. Now we have this reference one. We'll go ahead and hit save. We'll go back to the input. And then we'll close that previous preview. And then we'll hit preview now on the new one. So now instead of looking at the rolling window, it's actually just saying if the distribution of our new data here changed a lot from our training data set, trigger this anomaly error. And you can see that it did for all 3 of these now. And this is really cool because, again, you might not have that past 7 days data or anything right now if you're first putting a model in production. So right away on your very first day, you could profile your training data set and have that as a reference profile and then right away monitor against it. So that's like my preferred method of doing it most of the time if I don't have any other data to kind of compare against. So we can close this preview. Any questions so far? I'm going to go ahead and quickly go through probably the rest of this, but let me know if you have any questions. So back in our Colab notebook, we're going to write up a couple more things. So we looked at just the input data in this case. In this case, we could tell a lot from our input data, but we also want to measure our outputs. So the model predictions, how confident are the models, what kind of classes they're predicting. That can also tell us something else. And then we're also going to monitor performance over time. So using ground truth to get some more metrics. So let's quickly run through. We're going to monitor our model prediction outputs. And here, I'm just kind of running through those data frames again, making those predictions, and then appending them to a data frame. I think I need to update the way I do it, but everything should be fine. And if we look at the new data frame here, we can see that now it has the features, but also it has our predictions from the models. So we have our class output and we have our probability output. To get things into that output tab in ylabs, you just have to include the word output in your feature name. And the only reason really why you want to do this, have a separate tab, or one of the main reasons, I guess there's some other features around it too, but is if you have like hundreds or thousands of features in your models here, it can be really hard to find your model output. So having the tab just makes it a lot cleaner to find those outputs. So we have the word output in there. They'll automatically go into that tab when we write it up. And then here we'll write up the data frame, just passing in those class outputs and probability outputs for each day. And we'll look at those in a second. But I just want to note that, if I was actually doing this in production, I'd probably do these in the same step, have logging the data and the predictions at the same time. In this case, it kind of makes sense to break it out for the workshop and make a separate data frame because then we're going to add ground truth back to it. But realistically, I'd have something a little bit more like this. Here's an example of using it like in a BentoML API. We're calling classify on it. I'm just creating a data object or a Python object here. With those features, with the category, with the probability, all in one data object, and then I'm just going to log that data up. So again, broken out for the workshop, but you can do this all in one call, and again, it's very few lines of code. So this makes it look like a lot that we're doing, like looping through all the data frames and stuff. But if you actually set this up in your API or something, it'll be a lot less code. So let's go back to the ylabs platform. We'll look at this output tab. I think we need to refresh it. And now we have 2 outputs. We have that class output and our probability output. Let's go ahead and click into class output. Now we can already see something interesting here is, these first 3 days, they look pretty like they have the same distribution of predictions. It's about 50 each of each class. This is the profile that had the drift where everything went really high. This has almost all Virginica, but 4 versicolor in there. This other one that had kind of the bigger distribution at the top of max values. This also is a different distribution, right? A lot of Virginica as well, but still some of the other ones. And this one that was all zeros is all Setosa. And so this gets to the part of when I covered the intuition, does anyone have a guess why these predictions might look this way based on what we talked about in the KNN model? So if we look back at our KNN model, let me just bring up this picture again. Right here, we have our new piece of data, and then we're looking at the closest, in our case, the 5 neighbors. Some of them, though, like we didn't have any data validation built in. So even if you had a 0 all zeros, like we had that profile with all zeros, it's just going to be looking still at the closest ones, even though maybe a zero length shouldn't exist in our data set. So that's why that's all predicting Setosa. And then same with the other ones that are really high. If that data piece is, way out here and not even close to the other distribution, it's still going to make a prediction of the closest 5 neighbors in that case. So it's just kind of interesting. So you might want to add in something like that data validation into your pipeline. And that's something we talked about in the last workshop, where you could do that with ylogs, using profiles, making sure that the distribution of features is, above 0 and under 15. And if so, maybe you don't even make a prediction on it, or you log it in a different way. So that's why we can look at those model outputs and even kind of understand that something interesting might be going on there as well. And then if we look at the probability outputs, again, for those same days, we can see there's some changes. For these first 3 days, they're pretty much the same. This one has confidence kind of drop on some of them. Same with same with this one. And then this is interesting because instead of confidence dropping or varying, it's actually very high for all those zeros. Because again, if we went back and looked at the picture, it would be down here and it'd be only seeing Setosa, and it would be like, well, I'm 100% sure because that's all that I see. Those are all the closest profiles to me. So there's a lot you can gain just by looking at your data inputs like we saw, and also looking at your outputs. And we don't even have the ground truth yet, but we can tell that something is probably going on there. And maybe using this, like I mentioned at the beginning, you could set up the monitor and you can configure it to notify you by like email or Slack. We could also use something like PagerDuty to kick off some sort of automated job. So I actually did a cool talk about this using an annotation tool called Toloka, where it can detect data drift. And you say, well, I think something is going on here, but to really know for sure, I should go look at the data or have someone go label it so I can get the ground truth. And then you could kick off that job with the data drift happening. Have someone annotate that annotation data for you, or you could annotate it yourself. And then you can log that annotation data back to ylabs, which is what we'll do right now. So here, we're just going to append a ground truth column to our data frames. So now everything looks like this. We have our class output. This is the predicted output. We have our probability output, and then we have a ground truth now on there as well. So we'll be able to compare these metrics and see how well our models are actually performing. And then we're going to write those up to ylabs. Again, pretty similar, except for instead we're using this .log classification metrics, and we have to pass in the data frame, and then we tell it to look at these 3 columns: our ground truth, our class output, and our probability output. And that way we're going to be able to get the performance metrics. So you could have someone annotate your data and then look at the whole performance and actually see how good or poorly your models were performing on those days. And then if you go look at that data and say, well, that was either a quality issue, we need to fix something in our pipeline, or if it was data drift and just that your data changed, but in a natural way in the environment, and now you want to account for it in your model, you could retrain your model with that data that drifted, and then hopefully it should be performing and making better predictions. So here in our performance tab, we have things like you might expect: accuracy, recall, false positive rate, precision, F1 score, and then the confusion matrix for the latest day. And if we do look at basically most of these metrics, right, like let's just use accuracy. In this case, we can see that those first 3 days was pretty accurate in the 90s. And then it dropped a lot on that one that had the big drift value to 34. Oops, sorry, my screen fell. Sorry about that. And then, so basically all those, like, right, we can see that they dropped in. And someone asked a really good question. They said, why is the input and output difference in that first graph? And I'm glad you called that out. So this is actually kind of cool too, because if you had a whole bunch of input data and for some reason you weren't making predictions on that day, that could be a good indicator that something happened as well, right? You had input data, but for some reason your model didn't log any output. So maybe something's broken in your pipeline there. In this case, why we have that showing up is actually if we go back to our notebook, when we wrote that very first single profile before we backlogged, that went on 315. And then we actually just looped through all the data frames again and wrote another one on 315 but we are only logging predictions for one profile. So that's actually why that says that. But it's cool that you picked that up, because that's something that you could also see, like, what's going on here? Something might be broken in my pipeline, just measuring throughput. And I think you see that here too in I think one of these tabs as well. One of them, yeah. So in our model outputs actually has the same thing. So without even monitoring performance, again, you could kind of set up a monitor or look at this and say something might be going on in my pipeline. So I know that was pretty fast. We went through a lot, especially if you haven't done anything like monitoring before. We just quickly covered a lot of the concepts very briefly, and then we went through, kind of looked at how we could do all those things in this platform here. If you want to explore more, totally recommend checking out the other resources in here. Also, there's a link I'll copy in the chat as well. If you want a certificate for going through this workshop, you can fill out the form here. That was a long link. I think that should work. But if you have the notebook, you can click on it for sure. And then also, you can learn more about ylabs here. Like, we just kind of scraped, some of the features. These are kind of the bare minimum you should probably be doing if you're in the like, if you have a model in production, you should probably be monitoring the input and the outputs even before you get the performance data like we were seeing. That will kind of show you a lot what's going on. And you can learn more about different writers too. So we use the writers to log to ylabs, but you could use ylogs and do all sorts of similar things with it in your own platforms and environments. And again, if you want to go back into that first part, if you weren't here for the last workshop, I'll just quickly, I won't go through everything, but I'll just highlight a couple things if you want to come back. If you open up that ML Monitoring 101, there's some of the similar stuff. We looked at drift, kind of like we did today, but then we quickly get into using ylogs itself, just the open source library in a Python environment. And here you can create, well, I won't run these, but you can create cool drafts to visualize and get drift numbers right in your environment. And then also you can do things like data quality validation. So writing those tests to make sure that, in this case, that every petal length is, greater than 0 and less than 15. So you can do cool stuff around data validation and drift directly in your Python environment as well. But it doesn't have a whole managed thing, like over time, detecting for drift and stuff over here. But it's really cool to use it in some applications like edge devices. I've done stuff with like computer vision on edge, and it's hard to like pass all that data out and monitor somewhere. So doing some of the data monitoring on device and then passing out the relevant data is pretty cool. But other than that, that is kind of the end of today's workshop. Does anyone have any questions? Did this seem interesting to everyone? Like, were you like, this is cool, maybe this is something I would use in a project? Again, I'll share the Slack link out. That's going to be a good place to stay connected and ask questions later. So if you did think it was interesting and you try using this in whether it's a personal project or for university or something actually in production, you can ask questions in the Slack. Oh, and if you want to stay connected, you can also connect with me on LinkedIn as well. Yeah, I'll wait around just a few minutes because I do see quite a few people still in here. I even saw like a big spike of people join recently at the end. So I think on YouTube, you can always, even before it ends, I think you can rewind and go back to the beginning. So if you do want to follow along, you can rewind back. But this recording will be at the same link that you're at as well. So you can always come back to this and watch it there. Has anyone done ML monitoring type stuff before? Or still, I don't think there's been people talking, but I don't think anyone answered the question if they've ever put a model in production before. Someone asked, what about ylabs pricing? There's a pricing page you can go to. Oops. Oh, right there. This should have all the information there that you can scan at. And then also, of course, if you actually have a project in mind and you want to talk more about it, I'd recommend hopping on and like scheduling a demo specifically about your project and what pricing could look like for that. I'll share that link as well. The link is also in the description, so if you want to go to that ylabs contact us, that should have any kind of relevant stuff in there. Or sorry, that should be a good place to schedule a demo. The pricing page should probably have what you're looking for as well. But yeah, if you have a project in mind, definitely better schedule a demo. Talk to one of our awesome architects that can kind of tell you what might work well and how to, perform monitoring on your data. Today we just showed tabular data, but a lot of people are using embeddings or images, and we can talk about that there as well. Someone said they hadn't placed a model in production, but ylabs looks very useful. I think so. Yeah, well, monitoring in general is useful, so I think we make it pretty easy with ylabs. In fact, it's funny because I was doing stuff with other models and talking to, like, looking at using ylabs in some of the stuff there, and then I was like, this looks really cool. I kind of want to work on that problem. So now I'm at ylabs helping people with the same issue that I had before. But yeah, monitoring production is definitely something everyone should be doing. And a lot of people, like, will think about doing it later. I recommend doing it right away, even just the bare minimum, like we were saying, the data, the input data, maybe the model predictions. Because if you're not, eventually you might have something go wrong. And then that's when a lot of people go, oh, I really need monitoring because that could have saved me a ton of time or a ton of money later. So I definitely recommend putting it in as soon as possible. But with that, I know we're way over time. So I am going to end the stream. If anyone else has any other questions, connect with me at any of those places, Slack or LinkedIn, and ask them there. Thank you, everyone, for coming. It was really fun, and I always really appreciate when people do ask questions and talk in the chat, so extra thank you to everyone who participated. And I'll talk to you all, hopefully, in the near future. And we do have the other workshop coming up. The links were in this notebook. You can go to the ylabs/events, and that should bring you to the page where everything is coming up. The next one, we're going to be talking about segmentation and kind of diving deeper into how to look at our data more in a fine-tuned way. So that's going to be like, we can chop up our data, look at how it's performing on certain classes or features, and detecting whether there's any potential bias in there. Someone asked from my teacher, no ML oops. So ylabs will replace that task. Oh, so it might be hard to read. It's kind of a joke. It's no more ML oops. So it's a play on words, obviously, of ML ops. But ML oops is like, we were joking around. That's what it says, or that's what happens when you make an ML oops, or when you make something bad happen with your data or model in production. So play on word, no more ML oops. Someone else explained it. No more ML oops, as in ML mistakes. Yeah, play on words there. I think it's pretty funny. All right, so I'm gonna go ahead and end the stream. Thank you again, everyone, and I'll talk to some of you later, I'm sure. Have a good day.